Hey guys, in this video I'm going to show you how to use the conversion flowchart to solve some of our more complicated chemistry dimensional analysis problems. So here is our conversion flowchart. It's just a visual guide to show you how we switch from one unit to another when we're talking about any amount of a formula. Here that formula is called X. So if I give you a number connected to a unit that involves a formula, we want to find that unit on this chart, and whatever we want to switch it to, we want to follow these arrows down to see what conversion factors we need to use to change our unit. Say for instance, I gave you a formula that was in the unit moles, and you wanted to switch that to grams. So if we look at our chart, to go from moles to grams, we know that we need to use a molar mass, and you find that number from the periodic table. If you need to learn how to do that, check out the video specifically for molar masses. So best way to get started is with some examples here. First one I have, okay, our question is, how many atoms are in 12 moles of copper? So I'm going to use this flowchart to figure out what conversion factors to use. But first I need to start off my dimensional analysis chart. I have a blank one set up here already. So when we read our question, we always want to find out what our goal unit is first. How many atoms are in 12 moles of copper? To answer this question, the unit would be atoms. Okay, so I'm going to go over here, write atoms down, and I'm going to also include my formula, atoms of copper. Okay, I start with 12 moles of copper. That is what I have to begin with in this problem, so I'm going to fill that in right here. 12 moles of Cu, copper. Okay, so now I look at my chart over here. My start unit is moles, which puts me right in the center of my flowchart, and my end unit is atoms. Okay, I know it says particles up here, but that is a general term. Atoms or molecules could be particles. So I'm going to go from moles to particles, aka atoms. All right, so to get from moles to particles, I'm going to need Avogadro's number. Right? This number is always the same. Right? Doesn't matter what the formula is, there's always this many atoms in 1 mole of that formula. So I'm going to write my conversion factor down over here just so you guys can see. It would be 6.02 times 10 to the 23rd. In this case, it is atoms of copper, and that is equal to 1 mole of copper. Okay. No calculation, no multiplication, addition. All we do is repeat this number and we put in our proper labels and formulas. Okay, so I have this conversion factor here. Now I want to write this conversion factor into my chart so that my units cancel out. I'm trying to get moles of copper to cancel out, and I want to end up with atoms of copper. So moles of copper, this half of my conversion factor, needs to go in the bottom so that it cancels with the moles of copper in the top. So 1 mole of copper in the bottom. Now the other half of my conversion factor must go in the top of my chart now. I'm going to put this big long number up top. So 6.02 times 10 to the 23rd atoms of copper. All right? Just looking at the units, don't worry about any of the numbers here or doing any math yet. We see that moles of copper cancel out. We're left with atoms of copper. That is our goal unit, so we are good with our conversion factors. We've lined everything up the right way. Now all we need to do is the math. So we're going to multiply everything that's in the top of the chart and then divide by everything that's in the bottom of the chart. So 12 times Avogadro's number here. I did the math ahead of time, but you guys can plug that into your calculator. This will give us exactly 7.22 times 10 to the 24th atoms of copper. Okay, so this would be our end number here. All right. So that is one example where we started with moles and needed to go to particles. Let's take a look at another one. In this example, we're going to go from moles to grams. So if we take a look at our chart again, we're going to we're going to go from grams to moles. All right. Once we figure out our start and end, we'll see that we'll be beginning at grams and going to moles. To get from grams to moles, we'll need our molar mass. So let's line up our start and our finish in our chart. We know that we want to find how many moles of water there are. Right? That is our goal unit. So I'm going to write this down on the side here, moles H2O. We begin with 278.6 grams of H2O. I'm going to fill that in here in my chart. Okay, I have my start, I have my finish. The way this problem's written is really easy to see that this is our only option to start with, and to answer the question we need to be in moles. So we look at our chart from our flow chart. So to get from grams to moles, we need a molar mass. To find this molar mass, we'll have to look at our periodic table. In our previous video, we did find the molar mass for H2O already. If you need help finding molar mass, look at this other video. But that conversion factor is going to be 18.016 grams of H2O. I found that from the periodic table. That is equal to 1 mole H2O. All right, so I have this conversion factor. I need to see how to line it up in my chart so that grams H2O cancels out and I'm left with moles of H2O. Grams H2O is on the top, so I need grams of H2O in the bottom right here. I take this half of my conversion factor, fill it in on the bottom, 18.01 grams of H2O, and I'll need to take the other half and put it into the top of my chart, 1 mole H2O. Not doing any math yet, just looking at our units. GH2O, GH2O, there's one in the top, one in the bottom, they cancel out. I have moles of H2O left. That is my goal unit, so I'm good. I can go ahead and do my math. 278.6 times 1 is just going to be 278.6. And then I divide by everything in the bottom, which is just one number, 18.016. Once you plug that into the calculator, you will find that it is 15.464 moles of H2O. That goes right along with my N unit. 15.464 moles H2O. And that is my final answer. Next video, I'm going to show you one where we go all the way from grams to particles across both conversion factors that we have. So check out my next video for that one.